This is Seth Bayer back at you with another snow sports accident reconstruction case study. I'll give you a little background on myself before I get too far into this. I've done that already, so this one will be quite brief. This is me in the 1982 NCAA National Championships in Lake Placid, New York. Giant slalom, a race that I won and allowed me to keep my scholarship so that I could move on and continue my education, which was University of Colorado, Bachelor of Science in Mechanical Engineering. I've been involved in some very interesting things in my career, and I won't go into that, but you can look at this CV at your leisure if you even are interested in that. One of the most interesting things I worked on probably was my involvement with the snowboard industry, which was with a company called Airwalk out of Carlsbad, California. I had invented some mechanisms for step-in bindings for soft boots for snowboards. And we developed it over several years and ended up doing production in Italy in the late 90s for 3 years, which was one of the best jobs and most satisfying experiences. I did do a lot of testing on snowboards, Chamonix and Annecy, France, and all over the United States as well. So this case we're going to talk about right now involves GPS tracking data. And this is data that's stored with respect to the position of the skier, and there's various names for it. This case involved I'm showing to you is used at what was called ski tracks. The GPS data, it's an objective source for skier position, and samples are taken every 2 seconds, so position can be determined and speed can be determined in that regard as well. So it's extremely useful in taking this information and actually putting it into a scene and knowing where somebody was and how fast they were going. So in this case, it was a skier-skier collision. Now, the man was using the Ski Tracks mobile app. He represented himself as an advanced intermediate recreational. He had rental equipment. He was blind in his right eye and said he was listening to music in his earbuds. His recollection was skiing right, was hit by other skier from behind, fell on left shoulder. The woman was a recreational skier. She was a volunteer host at Breckenridge, and she owned her own equipment. She was not using ski apps. So this occurred on a trail called Country Boy, Blue Square. The man was coming down Briar Rose, which merged into this Country Boy trail, and it was an area of quite a few trails merging and diverging, and it was right under a ski lift. The woman's recollection was that she saw the guy. When she got close to him, she saw that he was looking totally down at the ground and he was headed right towards me. She yelled at him, and then she got hit. So in this case, the reconstructed methodology I used was different than the other cases. There was no equipment available, had ski tracks data for the man, deposition testimony, which was from both parties, but allowed us to establish the path of the woman. And I also did a site inspection and did a LiDAR scan there because we animated this reconstruction after it was complete. So the whole focus is, as always, is to determine who was the uphill skier in the moments leading up to the collision. This is a trail map showing where it happened. I'm calling out Briar Rose and Country Boy. Understand that trail maps are never accurate renditions or versions of what actually exists. They're artists' renderings, and they're very great for navigating a ski area, but don't represent what actually exists. This is an image from the Ski Tracks app, and it shows the path of the man as he was descending from where he got off the lift up here, descended all the way down. This is where the collision occurred. This is a closer up version or view of the collision location. You can see the guy was coming down pretty much along the, not center line, but not near the edges. Came through here, and then took a right turn, which is consistent with his testimony, and the collision happened here, and the data stopped moving. What's significant here is it's just a plan view or overhead view. You can't see anything about the topography here, so it's only useful in showing the path. Here is another image out of the ski tracks data, and it shows his speed along that run, which is interesting. It shows, at the time of the collision, he was probably around 22 miles an hour based on the graph only. Shows the time of day that it happened. So in this case, I went up to the ski area, Breckenridge, in mid-May with the LiDAR scanner. The area was closed, but there was snow, so it was actually a pretty easy hike getting up in the morning. Well, it was still kind of firm. And so we took these scans, multiple scans, and the results were the scans were joined together, and we created a three-dimensional model, went into AutoCAD, and then Autodesk Max 2020, which was a visual and animation program. The paths of both skiers were put onto the surface data in that model, and the elevation for each skier as they approached the area of impact was used to determine who was above and who was below. The man's data came from ski tracks, and the woman's data came from her deposition exhibits, where she drew in on some photos her path of approach. The collision was determined from the GPS data to have occurred at this latitude and longitude, which is important because it gives an absolute reference in global coordinates at the ski area. The elevation was about 10,350 feet. So here's a photograph looking down at the area where the collision occurred. When I got to the scene here, I used my own GPS device to locate those coordinates that were shown in the data and marked it. It was somewhere out in here. And also I put down these red cones because when we're doing LiDAR scans of snow, everything is so uniform, it's hard to join the scans. It takes multiple scans to create a model. Of course, each scan will get trees and lift towers and things like that, but there's also large expanses of open snow. So these cones get used to give points that can be overlapped in adjacent scans. So that's the LiDAR scanner right there. It's a small device, quite portable, easy to carry around. This photograph is, again, looking down the hill towards the area of impact. I put in the paths of travel. This is where the man came along, and the woman was here. Quite obviously, intuitively, you can see here that the man was going downhill, and the woman was more or less traversing. This is my assistant right here. You can see her shadow, but I airbrushed her out so that no one would be distracted. This is an overhead view from the LiDAR scan data showing the paths of travel of each skier. And it's just the raw LiDAR data, which is pretty good. And again, you can see the round areas where the scanner was set up directly below it. No data gets taken, but that's a very small surface that's not recorded. Here is tabular data from the Ski Tracks app, and it shows latitude and longitude. This is for the last 10 seconds before the collision. There's some other data like altitude, but most of it is not important for this. From this data, and as I pointed out, one data point gets taken every 2 seconds, which is about a half a hertz. Then the speed's calculated in the app, which is taking the distance and dividing it by time. I also double checked that myself, just as a matter of course, even though that's a very simple calculation and quite easy to install on an app for a phone. So we've seen the graph. This is consistent with that. It shows the speeds leading up to the collision, 6 to 8 seconds before 15 miles an hour, 4 to 6 seconds, 17.5. This is average speed, of course. 2 to 4 seconds before 20.7, and 0 to 2, 20.6. This fits with what we know about the topography because he turned and he started going straight down the fall line. we learned from the LiDAR data that the grade of approach during the last 40 feet for the man and the woman was different. For him, it was 17% to 23%, and for her, 7% to 13%. So clearly, she's on a flatter path of approach. Her deposition testimony, she provided a range of speed. I think the mid-range was 14 miles an hour. So we used that for her and then continued with our analysis. Here, after plotting her path along the LiDAR scan data and knowing the reference point for where the collision occurred, we could then locate her vertically from the area of impact, that's in blue here. And for the man, we also located him vertically in the area of with respect to where the collision occurred. The time is 6, 5, 4, 3, 2, 1, and 0 seconds. And this is distance from location. So clearly he was going faster than her too. And what's significant though is the difference in vertical between the two as they approach the collision area. This is that same information. This is the information that was used to create this visual representation, which is easier for most people to understand. So then from the LiDAR, we created a virtual model, made it look a little prettier. Lift towers are as scanned but surfaced. We put pads on them. There weren't any pads there during our inspection. We didn't add chairs, but that could be done if it was necessary or in any way would help with the presentation. So here are the two skiers. Here's the man and here's the woman. This is them about 4.9 or 5 seconds before. I didn't mention here, but it's about 12 seconds before the collision. They're both visible to each other. Here, about 4.93 seconds, she's passing behind the tree. So this is probably the only area where she's not visible to the man when she's downhill of him. However, he is blind in his right eye. This is 5 seconds before, showing roughly where the sight lines would have been obstructed for him had he been looking to his right. 4.2 seconds, she comes out from behind the tree. Now she's fully visible. This is as they get closer, 3 seconds before collision. This is just another representation of where the sight lines are open and the red designating where they're not open. So essentially, the sight lines are open for both skiers. Now, this is an animated view or model showing the approaches of the skiers. What we do is we create an animation, and then we can place a camera anywhere in this animation to show what the different perspectives were. This is the same animation, different camera view, showing the skiers as they come down, and the section right there where there's obstructed sight lines. Plenty of opportunity for the man going downhill to see the woman. Here's another animation run, but with a slightly different camera view where we're tracking the male skier. And in the creation of these models, we use GPS coordinates, which give us background information for what exists there. Here, looking uphill, so this is a pretty good perspective for seeing both of them for the entirety of their approach. And the clock runs so we can understand how much time each had, particularly the downhill directed man. So back to the Colorado Ski Safety Act, we know each skier has a duty to maintain control, but that the primary duty is on the skier descending to be able to avoid skiers and objects below him. So we know summary was downhill skier was the woman. She was below and to the right of the man, no sight line obstructions. The man reported no vision in his right eye. His testimony and GPS data shows he did take a right turn just before the collision. He failed to maintain a proper lookout for skiers below him. What was also significant is, he mentioned his blind eye, but he said he was listening to Christian music in his earbuds. at the time of the collision. So I think he felt he was appropriately guided, and maybe that made up for the loss of a right eye, but it obviously didn't. Again, this is me, Seth Bayer, your accident reconstructionist in winter sports.